It's been a long time coming, but we can finally create native charts inside of Notion. With just a couple of clicks, you can add a chart view to any database, and with charts, we can make some really cool stuff, like this line chart that shows all the Pokemon releases by generation. And we could also create some more useful and practical charts that you could actually use with your team, like this chart that groups your tasks by their project, this one that groups it by assignees, it's basically a workload chart, and we could even create really powerful sales dashboards. Say you have a sales database with tons of sales records, you got some products, you got some customers. With charts, you can very easily see who your biggest spenders are. You can graph your sales by month. You can even create multi-series comparison charts, which would let you, for example, compare the previous 30 days to the 30 days before that and see how your sales varied day over day within those two periods. Charts are awesome. But what are charts? What is a chart? Well, number one, a chart is a synonym for graph, which means I get to do this. Look at this graph. I would apologize, but I'm not sorry whatsoever. Charts are also actually just a new layout type in Notion's database tool. Now, because charts are just layout types in databases, and because database views are blocks like pretty much everything else in Notion, you can put a chart basically anywhere. It allows you to create these really cool dashboards with the 4 different chart types that we have here at launch. But where it becomes really interesting is when we get into the settings of our charts, because that's where we get to work with data. And data is what I've been preparing for this video. So let's build some charts. I have prepared 3 different data sets, a tasks and projects database with lots of different sample tasks and projects, naturally, a full Pokedex, the one we used for the Notion API tutorial I made a couple of years ago, and a huge sales database with hundreds of sales records. We have a whole bunch of customers and products attached to those records, and using those data sets, which I have made public in the description down below, we are going to create some charts at 3 different levels of complexity. So let's dive right in. We're going to start with a very, very simple chart, and that's going to show you how to actually create your first chart. So here we're on this page called Simple Chart, and as you can see, if I go ahead and make this a little bit bigger, we've got some Pokemon. This is not a full Pokedex. This is just 9 different records here, the Gen 1 starters, and we have some of their stats, the HP, the attack, and the defense. Now this is a table layout, but if we move over to this tab right here, you can see we have this nice little bar chart that is showing the HP of each of our Pokemon. And because we are using the name property here on the x-axis, we also get to see their page icons as well. It's a special feature of the name property. So to create this chart from scratch, what we are going to do is go over to a copy of this page that I created that doesn't have the chart already. For each of the data sets, I've done this. I've got a finished version, and then I have a blank version that just has our data. So to create our first chart, we can create a brand new view here in this database block. We're going to choose chart as our layout type, and then we're going to get a whole bunch of options here. So we have chart type as an option, and I think I'm going to be zooming in and out for this video because sometimes the chart settings are a little bit small here. We've got a vertical bar chart, we've got a horizontal bar chart, we got a line chart, and we have a pie chart. So to recreate our first chart, we're going to go back to our vertical bar chart, and then you can see we can choose what property from the database to graph on the x-axis, as well as what we're going to show on the y-axis. And I would like it if I could get a little bit further down and show this whole thing here while also bringing up the settings. That's a little bit better. So on our x-axis, we want to show the HP of each of the 9 Pokemon in our database, which means that the Pokemon themselves need to be our x-axis property. So we're going to go in here and find the name property that is basically the primary key of this database, if you want to use database terms. And now we can see our Pokemon on the x-axis just like that. Then on the y-axis, what to show is going to change from attack to HP. But notice we have quite a few options here. We could show values, we can show a sum, we can show an average, all kinds of stuff. And these become very useful later on when you realize that sometimes we're not going to be grouping just individual database pages on the x-axis. Sometimes we're going to be grouping groups that actually are composed of multiple records from the underlying database. And that is why these number properties and their options can be very, very useful. But here, I think values is going to be just fine, and we can double check our work by checking Blastoise's HP over in our data table. So HP for Blastoise 79, perfect. Now, the last thing we want to do here is sort this, also maybe hide our database titles. We have a little bit of room here. So we'll go back into our chart options. And now that we've chosen a number or numeric value for our y-axis, we can go up to the x-axis and we'll be able to actually sort by that. So instead of name from A to Z, we're going to go with HP high to low. There's also an advanced section, and you can actually add a sort from other properties here. So if you wanted to say sort by type, you could do that. That is pretty sweet. But for now, we're just going to go back to our sort by, and we're going to go with HP high to low. And there is our very first chart. Now, if you want to make the chart look a little bit different, if you have different aesthetic tastes here, we've got some style options. So if you go into color, there's auto color. There is a colorful setting, which I think this is actually automatically defaulting to. And then you have a whole bunch of more monochromatic, maybe would be the word here, options that I personally don't like because they tend to be sort of random in their hue distribution here, or their luminosity distribution, and also their transparency distribution. But you do have those options. I'm going to go back with colorful here. And then we also have chart height. We have grid lines that we can show. So if we want vertical ones instead of horizontal, we can do that. We can do both if we want to. We can show our axis names. So like that, you'll see HP and name. And if we don't want our data labels, we can turn those off as well. You're still going to see them if you hover over an individual value. So turning them off can make things just a little bit more aesthetic. Now for our next chart here at level 1, earlier I mentioned that these different numeric options you have here for number properties can come in handy. That is going to be revealed for our next chart by going over to our Pokedex right here. And in this example, we're going to create a chart that actually shows the average HP of each Pokemon by type. So instead of graphing individual Pokemon here on the x-axis, we have their types here. And I think we have around 905 Pokemon in this Pokedex. It doesn't have the latest generation on it. But as you can see, for dragon types, there is an average of 81.55 HP across all Pokemon that are dragon type. And then over here on the right, poor little bug types only have 56.53 average HP. So we're going to build this chart next, and you're going to see how this grouping criteria works on the x-axis. Going over to our little working copy of the Notion Pokedex, we do have a couple of charts in here, but what we don't have is that HP average chart. So let's go ahead and create ourselves a chart one more time. We're going to go ahead and link a database. We're going to call it Pokedex video version, and we'll call this average HP by type. So once again, we're going to go with a vertical bar chart. We could do a horizontal bar chart. We could do a line chart. That would work fine as well, but I think vertical is going to be totally fine here. And then on the what to show area, I think I'm going to try to go down and show this x-axis. On the what to show area, instead of the name property, we're going to go and find our type property. Okay, so now that we've chosen type, we're going to go ahead and change our what to show on the y-axis from count to HP, but this time we're going to go with average. And that is going to average things across the entire database. Once again, we're going to go ahead and sort by average from high to low. And just like that, we now have a chart that is pretty similar to the last one. But as you can see, our x-axis criteria represents for each data point a group of records from our Pokedex, not just a single record. Moving away from the realm of Pokemon to something a bit more practical, now we have a project dashboard where we have tasks, and we also have a projects database where projects are related to tasks. So for example, I can go into this engine rebuild setup project, and you can see there are tasks associated with this project, and each one of them has a status. So what we're going to do in this little chart challenge is we're going to create a tasks done per day chart. And this, I think, is a really practical, really useful application of charts. How many tasks did you or your team get done each day? Now, this is actually driven by a simple automation, so I want to quickly show you that. If we go to our tasks database, we can go to our view options, and in automations, you can see that I've created a set completion date automation. Essentially, when the status of a task is set to complete, we are going to set a property called completed to today's date. So to demonstrate that, if I go with organized tool storage and I set this from not started to done, then I can go down to organized tool storage in the complete area. And just like that, it is now completed as of August 15th, which is today's date. And if we go back up to our tasks done per day chart, we can see that August 15th is now a x-axis value on the chart because we have a data point for that value. So to create this chart, we're going to go over to our handy dandy little working copy of our project dashboard. We're going to create ourselves yet another chart view. This time, we're going to select the line graph instead of the vertical bar graph. And what to show is going to be our completed dates. And now with date properties, you can see there are quite a few different options here. We have relative, we have day, week, and year and month, so on. So basically whatever you want to graph, you can choose here, and we're going to go with just day. I think that works perfectly well. And actually with this one, we're done because what to show is already set to count. And that is what we want to see here. We want to see how many tasks were done each and every day. So this is a deceptively simple chart to build, but realize it is actually driven by this completed date property. Now, earlier I showed you the automation, which automatically sets that completed date property when you mark the status as done. If you are on a free plan, you don't have access to automations, you could very easily just set this date manually, but you do need some kind of property that is going to track the completion date of the task. That way, there is a data point that can be mapped on the x-axis representing that day. So set it manually, use a Pipedream free plan script, do it with the API, or use Notion automations if you're on a paid plan. Either way, that is how you would get a chart like this. Moving right along in our tasks and projects database here, we have another chart which actually shows our tasks by their project. And this introduces yet another concept, which is grouping on the y-axis. So here you can see that we are showing how many tasks we have within each of our projects, but we also have groups indicating the status of those tasks in the projects. So to create this chart, once again, back to our little working copy, we're going to create ourselves yet another vertical bar chart. So coming down here, we're going to choose chart. We're going to find that vertical bar chart already selected. And this time, our what to show property is going to be our project relation. So if you aren't familiar with relations, once again, check out the Notion databases for beginners video. I'll have that linked in the description down below. Essentially, a relation allows you to take one database and another database and relate them together. So say you had a projects database and a tasks database, a relation property allows you to associate individual task rows or pages with a specific project row. And typically this is called a one-to-many relationship. A project is going to have many tasks, but each task in a project is just going to have that one project. So here we are taking advantage of that relationship to show our projects here on the x-axis. Now, it's not really useful for us to show tasks that have no project in this case because all of our tasks are part of projects. So we can actually take this little omit zero values option here on the x-axis to get rid of no project. And then to make this graph just a little bit more useful, we can also group by on the y-axis and use our status property with either the options or the groups. Now, status properties have these built-in groups. They're called to do, in progress, and completed. And within those groups, you can actually have multiple options. So maybe you could have like planned, an idea, and on hold, and to do, etc. So if you wanted to show all those options, you could. I think group makes perfect sense here. And just like that, we have a nice little vertical bar chart that is showing all of our tasks' statuses as groups in the y-axis values. And building off of the concept from that graph, we now have this workload graph. I think this might be one of the most useful and practical graphs you could add to your Notion workspace if you're using it for task and project management. This is actually showing the number of tasks and their statuses, both to do and in progress, for each person on a team. So here's the 3 people who are in this particular database, and we can see that I have 2 tasks in the to-do status and 1 in progress. Martin over here, he's got 5 tasks he's supposed to do and 3 already in progress. So we can see that Martin is kind of overworked and I don't have a lot to do. So if you're a manager or you are basically assigning work to a team, this kind of a chart can be super useful for distributing work in an even way. So to create this, we are basically going to do the exact same thing that we did with our last chart, but we're going to throw a little bit of a twist in, and this will be our first taste of having charts interact with other features in a Notion database. So once more, we'll create ourselves a chart. Let's call this one workload. And then we're going to go with a horizontal bar chart this time, and we're going to skip right over the x-axis and go to what to show on the y-axis, because the secret sauce of this chart, or I guess the crux of it, is setting this value to assignee. Now, in the y-axis, I can see each of these little user profile images, and if I omit 0 values, I can see the number of tasks that are assigned to each person. But this isn't really that useful yet because our tasks database has completed tasks in it in addition to tasks that still need to be done. So this is the first instance where we can actually bring a filter in and have it affect our chart. Just like filters can be applied to other layout types like tables and boards, etc., we can add filters in to actually change what data is behind this chart, what data, the number of rows in the database that are actually affecting the output of this chart. So to not see our completed tasks, we can go up to the filter criteria here. We can go to status, and we can say status is either to do or in progress, but not completed. And just like that, now we only see the ones that are within those statuses. To make this even more useful, we can hide our filter up here. We can go back and we can actually group our x-axis by those status values, just like that. Now, I do also want to point out that if you go into sort by here, you can change the sort criteria, but you can also change the visibility of these groups here. So we don't strictly have to use filtering in this view. I kind of wanted to show it to you just to show you how filters actually affect charts. But with visibility, we can kind of do the same thing. So you have the option either way. Now, all the charts we've gone through so far are at level 1. We are now moving up to level 2, and I'm going to show you a deceptively simple chart. Right here in our Notion Pokedex, we have a chart called single versus dual type. And this is showing us how many Pokemon in our Pokedex have 2 types, almost half of them actually, and how many in the Pokedex have 1 type. Now, this chart looks way simpler than our Pokemon by type chart right here, which is actually showing all the types, but how do you think you would create it? As you can see, when we go down to the Pokedex here, our type property is a multi-select, and we have a lot more than 2 options. So how are you going to create 2 possible groups out of all of these different options here to create this chart, which only shows 2 groups? That is where formulas come in, and that's why we are at level 2. With formulas, you can create additional groups out of the data that already exists in your writable properties, and then you can create charts using that formula output. So let's go ahead and do that really quickly by going over to our working copy of our Pokedex and creating that little chart. So before we can actually create the chart itself, we need to create a formula property. And that formula property is going to output either 1 if a Pokemon has a single type, or 2 if a Pokemon has 2 types. And it's going to be a super duper simple formula, so don't worry. If I open up any one of these records, I'm going to access all the properties in this database. I'm going to go to 9 more properties, and down to the bottom, I'm going to add a formula property, and we are going to call this type count. Now within type count, we are going to find the types property, or the type property, and reference it. And you can see here, it's outputting a list that includes all of the types as string values. If I click this little eye icon right here, we can actually see it's a list of text with 2 different values. Now, if I pass this type reference into the length function, we're going to get 2. And that's literally all it is. We get 2 types here. And for a Pokemon that has a single type, it is going to have 1 outputted in type count. So now that we have this property, we can use it in creating a chart. Let's go back up to our big old pile of charts here at the top. We're going to create a brand new chart, link the database to our Pokedex video version. We'll go ahead and call it single versus dual. And like before, we can configure. Let's go with a donut chart this time. I do like the term donut better than pie. I personally like donuts better than pie. I know. Sacrilege to some of you, but I do. And now we can show, instead of generation or instead of type, like we would before, we can show type count. And just like that, we get only 2 possible values, 1 or 2. Now, it's not limited to 2 values here by some rule or some limitation. It's limited just by the fact that within our database, the only values within the type count property are 1 and 2. If for some reason Nintendo decided to release a 3-type Pokemon in the future, and we added that to our Pokedex with 3 different types, we would actually see 3 items here. In fact, if we want to go ahead and do a little bit of fan fiction here, I'm doing some mad science, I'm like mixing up some potions, I'm pouring it on this poor creature, and all of a sudden it's now a grass fire poison type. I mean, that'd be kind of rad, actually. We're going to have 3 on this chart instead of 2. But we wouldn't do that to poor Ivysaur. Let's go ahead and get fire off of there, and let's keep that just to 2. Let us also move briefly away from the world of a children's video game that I just love using for examples in these videos, also that my friend Pat Flynn gets millions of views making videos about, to this sales data dashboard, because this is where we're going to create our next chart. So here on this dashboard, we've got a couple of cool charts here: top customers this month, VIPs with low recent spend. We're going to get to these in a little bit, but if we go beyond those, beyond our sales chart here, and into our customers database, I want to show you the next chart that we're actually going to build. If we go into the customer record for Scott Summers, who is a pretty great customer, except for in July, we can actually see a chart here showing Scott's sales by month. Now, these aren't sales across the whole company. These aren't sales for all customers. These are just things that Scott Summers bought. And we can see the exact data by going into this little 7 sales button right here, which is our sales records relation. And because we're using order numbers as our primary key, we'd have to actually click into one. So we can see here on May 22nd, he bought an orbital surveillance satellite kit. Scott, are you in the NSA now? Whatever, I'm not going to ask questions, keep on buying stuff from my spy store. So we're going to go ahead and create a chart like this. But more importantly, we're going to add a chart like this to a database template. So for every customer record in your sales database, you're going to have a similar chart. So to create this, we're going to go back over to our handy dandy little working version of this file. And to create it, we need to actually add one more formula property to this database, because as you can see, we have a sales table here where we have order IDs, we have a customer relation, we have a product relation, and we have a date. But what we don't have is a price or order total property right here. Now, we could add a regular number property and just manually type in how much money they paid, but because they're buying stuff, we can see that the stuff they're buying actually has prices. And I can briefly go down to our products table to actually show you how that works. So we have a whole bunch of products here: stealth cloaks, hoverboards, night vision goggles. Come on down to Tom's Spy Gadget Shop Extravaganza. It's just on the Missouri border where you can buy fireworks legally, and you can get yourself some great deals. I mean, a door bypass tool for $285, a jetpack for under $1,000. Don't tell OSHA about that one. And we have prices here. So if we're going to have sales records and we're going to relate those sales records to specific products that a customer bought, we might want to pull in those prices as well. So to do that, we're going to write ourselves a handy dandy little formula, and then that's going to allow us to see the order total. And then we're going to be able to create that chart showing all the order totals graphed on an x-axis of dates for a customer. So let's create that property really quickly. We're going to create another formula property. We're going to call it order total. Just like that. Let's give it a money icon. I think that might be pretty useful. And then we're going to go into the editor. And what we need to do here is reference the product relation. And as you can see here, with some records, we might actually have multiple products purchased in the same sale record. So what we need to do is somehow get the price of each of these products and add it up to get our order total. So how can we do that? Well, here we get a hint: list of blocks. If you have this little eye icon turned off, I highly recommend turning it on so you can see the data type that you're working with here. We have a list of blocks. So basically, we need to go block by block, in this case, page block by page block, and do something that can reach into that page block and get the price for that record. We can do that with the map function. And I have a whole video on Notion Formulas 2.0 that thoroughly explains the map function. But essentially, by using this little keyword called current, we can create a function that goes, again, element by element and does something, where current references the specific element that we're currently on. So the first time map executes on product, it's going to go and do something to this one. And then the next time it's going to do something to this one, and so on and so on and so on if we had a whole bunch of additional blocks here. So we're going to go with current dot price, and now this outputs a new list because map is essentially doing whatever this expression says to every single element in the input list and then creating an output list out of it. So now that we have a new list, all we need to do is pass that into the sum function, and there is our order total. Now we can hit done. Now that this formula property is outputting a number, we can also edit it so that it is a number formatted as a US dollar. And now that we have that, we can create our chart. So hopefully that little expedition into Formula Land wasn't too confusing. Now we can go over to our customers table. I'm going to go ahead and find Scott Summers. And it looks like we already have a sales chart that is filtered, if we look, to him as a customer. So this is only showing records where Scott Summers is the customer, or more precisely, where the Scott Summers record is the relational value on that sales record here. So one thing I want to do before we create the chart is add our brand new order total property we just created to this table view. I think that's going to be pretty helpful. And if we wanted to, even in the table, we could do a calculate down here, go to more options and hit sum. And now we can see the total amount of money that Scott has spent. But what we're after here is how much money he spent each month since he's been a customer. So to do that, we're going to create ourselves a chart. Once again, to the new view here, we're going to find ourselves a chart. This time, we're going to find our sales records video version database and go with a good old line chart. And what we're going to do is change our date day on the x-axis to date month, because we want to see the sales per month. And I think old to new is going to be perfectly fine. I think omitting 0 values is not needed here, because if he never bought anything in a month, we would actually want to know that information. But on the y-axis, instead of showing the count, that is the number of sales that have been made, we want to show the actual dollar amount cumulatively of those sales. And that is where our order total formula property comes in handy. So now we can see the sum of all sales, their dollar amount per month. But again, this is across all customers. So we want to filter this by the Scott Summers customer record. So we'll create a filter, customer, find Scott Summers, and there you have it. That is how much money Scott Summers has spent at Tom's Big Bonanza Extravaganza Spy Gadget Store that changes its name every month for the last 4 months. Now, to make this really, really useful, we want to actually put this into a database template so we can then apply it to every other customer record in our database when we create them. So I'm going to go ahead and click this little 6-dot menu here, click away. Now it is selected. I'm going to copy that to my clipboard. And now if we go back to our customer's database, we can find the little blue arrow next to new, find our customer database template that I've already created. So I'm going to go ahead and edit that. And we can paste that database that we've created. The only thing we need to change here is the filter criteria. Right now, it is pointing to the customer filter being Scott Summers. Well, if we left it like that, it would always be Scott Summers no matter what page we created, which wouldn't be very helpful. So instead, we're going to change that customer record from Scott Summers to the customer template. Now, this sets up my absolute favorite feature in Notion. I think it is the most powerful feature that exists in this entire tool, and it's called self-referential filters. When we choose to filter by a template here in the template, then when we create a new page and apply that template, say it's Beast or Psylocke, this filter is going to update to that page's name instead of the template. I'm going to show you how that works in just a second. Let's go ahead and add that template here on the chart as well. So instead of Scott Summers, once again, it's customer. And of course, because no sales records are associated with the customer template, we have no data here. That's totally fine. That is as we want it. But now that we have this template set up, we can go back to our customer's database and go to Indiana Jones, apply our customer template, and we are going to see all of the purchases that Indiana Jones made because, again, the filter gets updated when we apply it from the template. Again, this is my favorite feature in Notion. It's incredibly powerful. You can apply it in a zillion different ways. Go watch the databases tutorial if you haven't seen it. And that, my friends, is how you make this sort of customer-specific chart and how you apply it to every customer record in your sales database, just like that. Now, I know what you've been thinking this whole time. We went to that sales data dashboard and you were like, this top customers this month graph is sexy. I want to print it and put it out on my wall. How do I create that one, Tom? Well, that is the subject of our final graph or final chart here in level 2. And then we're going to go on to level 3, which is my favorite one. Now, before we create this top customers this month graph, I want to show you a simpler graph down here. This one is called sales by customer. And as you can see, the data points are a little bit different here. Scott Summers is our top customer with $7,300 spent at our shop. Thank you for your business, Scott. We got Hank McCoy, we got Nancy Drew, and their numbers are just a bit different than our top customers this month numbers. So to create our top customers this month graph, we're going to want to create a couple of different formula properties. First, we're going to create a total spend per customer formula property that is going to drive a graph like this. And we're just going to do that because that's going to make it a lot easier to understand the slightly more complex formula we'll need to actually limit the sales data to the last 30 days or this month. So to get started, we're going to go back over to our sales data worksheet here. And we're going to create these formulas in the customers table because, again, we want to get aggregate data about individual customers. So this should go on the customers table. Opening up Scott Summers one more time, we're going to go to Form Our Properties, and we're going to create a brand new property of formula type, and we're going to call it Total Spend. And we're going to be using that map function that we used a little bit earlier to basically get the total amount of money Scott Summers has spent at our store all time. So to do that, let's go with sales. Let's map into that array or list of sales page records. And then for every single record in the array, so that is represented by current for each iteration of this function going over the array, we're going to get the order total. So we're actually kind of stacking formulas on formulas at this point. And then once again, we're going to go ahead and sum, and that's going to get us all the money he spent at our store. Now we could go ahead and round this with weird rounding formula tricks, but instead of doing that, now this is outputting a number data type. We can edit the property, we can format it as a US dollar, and there you go, Bob's your uncle. Okay, the only reason I did that is because I want to load that concept in your brain so we can go ahead and do it a little bit more complexly for the previous 30-day spend. Now, if you remember, we want to graph the top customers this month. So essentially what we want to do is get the amount of money each customer has spent within the last 30 days. And that is going to involve basically doing what we just did, but with some filtering. So once again, we're going to create another property, formula type once again, and this time we're going to call it 30-day spend. I'm going to move it down here next to total spend at the bottom. We'd probably hide those records normally. And just like before, we are going to reference that sales relation. So we're going to get all of the sales that are associated with Scott Summers in this case. But before we can map into it, we need to filter this list so it only has records that occurred within the last 30 days. So instead of using the map function right now, we're going to pass this into another function called filter. And filter is really similar to map in that it's going to go through every element of the list that you pass into it, but it's going to output a new list that only contains elements from the input list that passed its test. So essentially in here, we're going to write a test to get everything that doesn't pass the test out of our output list. So for that, we're going to go with current dot date. And that's going to get our actual dates there. And we want to go with a date between function here. So let's actually go ahead and just copy that to our clipboard. We're going to go with date between. We can actually shift enter to get ourselves a nice little new line here. And we're going to get the number of days between now, which is a function, the date of the sale, just like that. And the unit is going to be days. So now that date between is outputting a number of days between now and whenever the sale occurred, say 37 or 15, the test we can write is it's less than 31. So now we only have 3 sales that occurred in the last 30 days for Scott personally. Now we can pass this array into the same map function that we had earlier. And there we can do the exact same thing that we did in the previous formula. Grab that order total, go ahead and sum it. And that is the amount of money Scott has spent in the last 30 days. So I'm going to go ahead and edit that once more to make our number format a US dollar. And now we have the formula value that we need to use for our chart. So going out of the customer record and to the top here, we're going to create ourselves a top customers last month or this month. And we could also do a specific month, but I think the trailing 30 days makes a bit more sense in this case. So we're going to do /chart. I think a vertical bar chart is going to be perfect for this one. This time, we're going to go with our customers database because customer records are what we want on the x-axis. A vertical bar chart is perfect here. Let's go ahead and call this top customers this month. And then instead of showing sales on our x-axis, we want to show the name property for our customers database. That's going to get us actual customer records down here on the x-axis. And instead of showing the total spend on the y-axis, we want to show the 30-day spend. And because this property corresponds to just one record, sum would be equivalent to values here. So values is perfectly fine. Finally, we can sort by the 30-day spend from high to low. And the first thing I notice here is that we have a lot of values here. So first I want to go in here and just go ahead and omit 0 values. That's going to make it a bit more readable. But even so, we don't really need Tony Stark and Jack Sparrow down here. They haven't spent a whole lot of money. And also, they are actually blocking some of our records from showing down here on the x-axis. For example, we've got Dirk Pitt here, but why is Charles Xavier not down here? Well, we've just got too many data points. So this is another instance where filters really come in handy. Here we can create a filter where, say, our 30-day spend is greater than, let's do $750. That's what gets you into the monthly rewards program at Tom's Spy Gadget Extravaganza Bonanza. So now we can see we got Dirk Pitt, we got Charles Xavier. I'm not sure why he's also yellow at this point, Scott Summers, and so on. That is how you create your top customers this month graph. And I'm going to leave it as an exercise to the viewer to create this similar graph here, VIPs with low recent spend. The hint I will give you is that if you remember from earlier, we had a checkbox property on our customers table for VIP status. Otherwise, this isn't a whole lot different, so I'll let you try this out for yourself if you're up for a challenge. And with that, my friends, we have ascended to the pinnacle of Mount Olympus. Level 3 is upon us. And here in level 3, we are going to create this, a multi-series chart. This is a chart where we have multiple y-axis values along our x-axis value. So here, what we're showing is the current 30-day period in a sales database versus the last 30-day period before it. So this actually allows you to compare the sales on a specific day in the period to the sales on that exact day in the previous period. So for example, if we're looking at the month of August, we could actually see the sales on August 1st compared to the sales on July 1st, the previous period. You could also do quarterly periods. You could do year comparisons. If you've ever used Stripe or Lemon Squeezy or any sort of like financial modeling tool, you're probably familiar with these. This is what we're going to build at this part in the video. But before we do that, we're going to take a little jaunt back over to our Pokedex because I want to explain a key limitation in Notion charts right now. When I click on one of these records in my Pokedex, Charmander, one of my favorite Pokemon of all time, we can see that there are several stats on this Pokedex database. We have HP, we have attack, we have defense, and so on. And wouldn't it be amazing to be able to actually graph all of these stats on the same chart? Well, I've actually done that over here in Google Sheets. You can see we have multiple different Pokemon here, and we can see all of their stats in the x-axis sort of grouped together for each Pokemon. Wouldn't that be awesome to do inside of Notion? Well, as of today, we cannot do it for individual stat properties or individual properties in general on a database. You can kind of do it, but to do it, you kind of have to do something a little bit roundabout. And I'm showing this to you just so I can impart a little bit of database architecture wisdom here. So if we go to roll your own multi-series, we can see that we have basically the same sort of multi-series chart here. We have Blastoise, we have Bulbasaur. So basically we have Pokemon records on the x-axis and we have multiple stats here on the y-axis in groups. The way that we have to do this is by creating a stats Pokemon table where every single record represents a stat value that has a type and then has a Pokemon record associated with it. We cannot do a multi-series chart using multiple properties on a single record yet. For now, if you want to do it, you have to create groups like the stat type property right here basically defines groups, HP, attack, defense, and then you'd have a table where there could be a record and it would be associated with one of those groups. So here, this value property for this row, 45, is associated with the HP stat type that will form a group in our multi-series chart. This one, our value property 49 and 62 and so on, are associated with attack. So that is how you can create multi-series up here. If we go into our chart settings, we can see that, of course, we're showing Pokemon on the x-axis. That's our x-axis value. Our y-axis value is that value property. We are taking the sum, which is going to get all of them. So for the Blastoise record, if we don't group here, we can actually ungroup, and we can see that the entire sum of all of its stats added together is shown here. Then we group by that stat value, and that's what's going to create our sort of multi-series style chart here. And of course, we can represent that as a horizontal chart. We can do a line chart like that. We can even come down here to our style options, and under more style options, if we want, we can actually have them stacked, which might be useful. So in this case, we can see how all those individual stats sort of add up to a final stat rating. So you can do a lot here with multi-series, but again, there's a bit of a roundabout way to get it to work if you have those stats as individual properties on a record already. Luckily for us, and I just showed you that to sort of explain why we can't do multi-series on those properties. Luckily for us, in our sales data, it's not as hard to model that because we already have a sales table that has individual records, and every single one of those records has a date. So the challenge here is to go from something like this, where our date is our x-axis value, and we have no way of splitting it into groups, to actually taking the date and splitting it into multiple possible groups. Going back to our current 30 days versus previous 30 days, the possible groups are the last 30 days, starting from today and subtracting 30 days, and then the period before that, from 31 days to 60 days ago. And we're going to show those as multiple series on the same graph here. You can see our x-axis is 0 days ago, 1 day ago, 2 days ago, a day ago, not necessarily from today, but from the beginning of the period to the end of it. And then, of course, on the y-axis, we have the data we want to see, which is the order total sum across all orders for that day. So to do that, we need to take our date property here and somehow split it into multiple possible groups. So to do that, we're going to go back over to our working copy of sales data here, and we're going to get into a bit more formula fun. So in our sales table, we've got our date property right here. And the first thing we want to do is go ahead and create a formula property, and we're going to call this property cycle. And what we want to do with the cycle property is figure out which 30-day period are we in. Are we in the current one, or are we in the previous one? If we're in one even beyond that, we don't really care. We're just trying to compare the current and the previous one. So basically this month and last month. And to figure that out, we are going to extract that information from the date of the order. So to do that, let's first use the lets function. This is a function that will let us basically create variables in Notion formula. And we're going to call this variable period. So with the lets function, the first argument is the name of the variable. We can actually go to the reference here and quickly look at it. So this will be the name of the variable. And then the next argument is going to be the value of that variable. And we can do that multiple times. So the value of A here is hello. The value of B here is world. The final argument is going to be the expression that is returned by the lets function. So A plus space character plus B equals hello world. So the period, the value of the period is going to be the date between, and it's going to be now, and it's going to be the order date with days as the unit. And if we just left it as that and we outputted period, we would get 1. Okay, so let's go to another record and let's see what it's going to look like if this was an order from, say, August 1st. Cool, we got 14 there. But this isn't yet telling us which period we're in. This is just telling us how many days ago this order happened. So instead of outputting just this date between now and the order date in days, let's go ahead and divide that by 30. And we can go ahead and take the floor value of that, which basically is going to send the number to its lowest next integer. Now we're going to get 0. And if we find an order that happened more than 30 days ago, if we load more records here, we're going to be able to find them. If we get back into earlier in July, this is going to output 1. Now we could leave it like this, but because we want the labels on our graph to look a little bit more descriptive, we're going to, instead of having it output a 0 or 1, we're going to have it output a string for each possible condition. So down here, we're going to do if, and actually we'll go with ifs, so we can actually have more than 2 potential outputs. If period is equal to 0, we will say current period. Otherwise, if period is equal to 1, that would be the last period. So we'll say last period will be the value there. Otherwise, if it's neither of those, this is the sort of default condition, we'll output a blank string. So now the cycle is either last period or current period. That is giving us essentially the 2 different series that we're going to be able to graph on our chart. But to finish this, before we can create our chart, we need to create another formula that is going to represent the x-axis value. And that is going to be the day in the period. Is it day 0 in the period? Is it day 30 in the period? That's what we need to figure out. So let's create one more formula property. We'll call this cycle day. And like its name indicates, it is going to tell us which day in the cycle, whatever cycle we are in, it is. And to figure that out, once again, we're going to get our little date between function going here. We're going to take now as our first argument, and that is going to be the later date. We're going to get the order date as our second argument. Days is our third argument. It's the number of units. And now we're getting, again, number of days between now and the order date. But to figure out where we are in the cycle, we actually want to take the modulus of that and 30. So now, if you know anything about modulus, it basically means the remainder after dividing this value by 30, or if it is lower than 30, it is going to be whatever it is. This is always going to be a number lower than 30, and that means it's going to indicate which day of the cycle we are currently in. It's kind of like clock math. If I say 8 a.m. plus 8 hours, what are you going to get? We're going to go past 12 and you're going to get 4. It just keeps going past a sort of common stop point and then resetting the number over and over and over again. That's how moduluses essentially work. So now that we have our cycle day and our cycle, we can create our chart view. And this time we are once again going to go with a line chart. We are going to show on the x-axis our cycle day. That's going to get us, again, 0 through 30. We can go ahead and omit 0 values to get rid of that no cycle day value. And then we might want to actually sort this from cycle day low to cycle day high so we can get the most recent day in the cycle at the end, and we get a linear graph just like that. Of course, now we're only seeing a single series. So if we go back to our chart settings, first, instead of showing count, we want to show our order total sum. And then we can group by the cycle that we defined with our formula. And just like that, we get a multi-series graph, which looks a little bit messy here because we're showing data labels. So I think we're going to go into our style options and turn those data labels off just like that. Cool. And now you can see the value of outputting current period and last period instead of 0 and 1. It's just a bit more descriptive on the resulting chart. Now, I'm going to level with you. I did not think going through those 3 levels was going to take as long as it currently took. So this became sort of like a masterclass video instead of a new feature coverage video. I do want to briefly go over a few FAQs for this charts feature. Number 1, how do charts work on the free plan versus the paid plan? Well, charts are kind of unique in that you can use them to a degree on the free plan, but they're mostly useful on the paid plan. With the free plan, you get access to a single chart view, and I'll show you what happens if you go and create another chart view or duplicate a template that has a chart view if you already have one created. Basically, you got one right here, and then if you're on the free plan, it's going to say, hey, you've already used your one free chart. If you want to, though, you can delete or turn this one into another layout type like a table, and then you're going to claw back that one free chart that you can then use in another view just like this. So if you're on the free plan, I think charts are kind of good for running temporary reports or just having one permanent chart if you don't have a ton of needs for charts. Beyond that, charts are kind of a paid plan feature. Another question that I think a lot of people are going to ask are, can you export your charts? And the answer is yes, but it's a little bit different than you would normally export stuff. If you use the regular export feature right down here, like export this page, right now, the Notion team told me that charts are not going to export. It's just going to be a blank space right here, blank space, baby. Hopefully that's going to be fixed in the future. But in the meantime, you can very easily go below your style options and you can save your chart as a PNG. You can actually download it. You can copy it to your clipboard. And I think there's an SVG option as well for downloading. There's even these nice little background things. So you can share your charts on social media. You can put them in Slack, all kinds of stuff like that. That is currently how you can export your charts. Now you might be wondering what additional features are coming for charts in the future. I can tell you about 2 of them. One of them is a number type chart, which is extremely simple. It's just going to show a number, but because charts are an embeddable view that you can put basically anywhere, they're just a database layout type, you could very easily create a number like total sales in a period. Instead of this, it could just be like $200,000 we've made in this period, and you could put that at the top of a dashboard. So I think people are really going to like that. The other feature, which I am much more excited about personally, is something called drill downs. And that is going to actually allow you to click into your data points and see the pages or the rows in the database that are behind each data point. So you click here, you'd actually get a little modal here. It's going to show you all those pages, and then you could click into each individual page. That's going to allow you to drill down into your data from this sort of summarized view here way faster. And I think that is going to make charts a true game changer. Super excited for that feature. In terms of feedback I have for the Notion team, things I want to see, honestly, I'm really impressed with this feature right out of the gate. I would love to see more charts access on the free plan, but of course they do eventually have to make money. I totally get it. What I would really like to see is multi-series chart capabilities for individual properties on a database. Like I showed you earlier, we had a Pokemon record with multiple stats. I would love to be able to just easily show all those different stats in a chart without having to create that crazy multi-series thing that I showed you earlier. So hopefully we see that in the future. Beyond that, I'll be testing this a bit more, integrating it into my own workspaces. And within our customer community, if you've bought any of our templates like Ultimate Brain or Creator's Companion, we're going to be creating tutorial videos showing you how to integrate these charts into those templates. We're not going to be shipping these charts with our templates because, again, they're mainly useful for people on paid plans, and we don't want to restrict our templates to people who are just on a Notion paid plan. But we do want to have tutorials in our community that show you how to integrate useful charts that actually pull really cool data from the template content you have. Anyway, we have gone through a lot in this video. Hopefully you learned something. If you want to master Notion, the best way to do it is to sign up for my Notion Tips newsletter over at thomasjfrank.com/fundamentals. Link is in the doobly-doo, as John Green would say. Because we went through some formulas in this video, you might be curious about how you can master Notion formulas. We have a whole Notion Formulas 2.0 masterclass video right there. Check that out if you are curious. And if you want to learn Notion databases, if anything in this video went over your head, understanding databases fundamentally is going to be really helpful. Check out that full databases course right there, and I'll see you in the next video.